Hey everyone, welcome to this explainer. Today, we're jumping right into the Selina Middle School Mathematics textbook for ICSE Class 7. Now look, if you've ever felt that literal cold sweat break out when you flip a page and just see a sea of negative signs and fraction bars, believe me, you are not alone. But that's exactly why we're here. We're going to completely take the fear of integers and fractions today. We're cracking the code, learning the logic, and turning those scary rules into tools you can use with total confidence.
So it really begs the question, right? Why do those long math word problems, the dreaded statement questions, and all those super rigid operational rules cause so much panic? Well, honestly, it's usually because it looks like an entirely different language. It feels like you've got to memorize a million separate little things just to survive one exam. But here's the real secret. It's actually just a handful of really simple, logical patterns. And today, I'm going to walk you through a totally logical, step-by-step approach that's going to build up your confidence so much that you'll literally never be intimidated by these kinds of equations again.
All right, here's our game plan for today. First, multiplying negative integers. Then, the distributive property. After that, mastering the DMAS rule, followed by income and savings fractions, and we'll wrap it all up with simplifying complex expressions.
Okay, part one, multiplying negative integers. Let's get into it. Let's kick things off by cracking the code on negative signs and multiplication. What's actually kind of wild here is how this massive headache boils down to just one single foundational rule. Check out the sign of product column here. Literally, all you have to do is count the negative signs in your equation. That's it. If you've got an odd number of negative integers, say just one negative sign, like in 15 times negative 8, your final product is absolutely always going to be negative. So, negative 120. But if you have an even number of negative factors, like negative 15 times negative 8, boom, those two negatives perfectly cancel each other out, giving you a positive 120. Odd means negative, even means positive. It's really that simple. So, if there's one thing you take away from this part, it's this. Please stop guessing. The wrong way to do this is to try and memorize the outcome of every single equation on the planet, or, just randomly slapping a negative sign on your answer and crossing your fingers. Don't do that. The right way, the smart way, is just counting your negative signs to figure out your final positive or negative outcome before you even start multiplying the numbers themselves. Locking this one rule into your brain is the absolute key to avoiding those simple, frustrating mistakes, even when you're staring down a super long string of integers.
Moving right along, part 2. The distributive property.
Let's add another tool to our tool belt and see how this builds our math confidence. Imagine looking at a test and seeing 427 times 8 plus 2 times 427. Right? Your first instinct is probably to grab a calculator or start scribbling out some intense long multiplication in the margins. But wait, hold on. First, let's identify the common factor here. It's 427. Because 427 is sitting there in both halves of this addition problem, we can actually just extract it using brackets. So we pull that 427 out, and that leaves us with 427 times, in brackets, 8 plus 2. And suddenly, the magic happens. We simplify the bracket first, and obviously 8 plus 2 is just 10. So now our big scary equation is just 427 times 10. You definitely don't need a calculator for that. It's just 4,270. The distributive property is basically a cheat code that groups numbers together to turn a complex calculation into basic mental math. All right, up next, part 3, mastering the DMAS rule.
Look, if you don't have order in math, you literally just have chaos. So, enter the DMAS rule: division, multiplication, addition, and subtraction. Honestly, think of this as the strict traffic light system of the math universe. Let's look at this expression, straight from the textbook. 42 divided by 7 plus 4. Now, without any rules, you might be super tempted to just add that 7 and 4 together right off the bat. But DMAS acts as a red light for addition. You literally cannot go until division gets the green light. So we handle that division step first, turning 42 divided by 7 into a nice, neat 6. And then, only after the division intersection is totally clear, do we move down the road to addition. 6 plus 4 gets us exactly to our perfectly correct answer of 10. You've always got to follow the traffic lights.
Okay, moving into part 4, income and savings fractions.
Now that we've got those operational rules totally locked in, let's take a leap from the rule book out into the real world. When you get hit with a dense, chunky paragraph about some guy's salary and his expenses, don't panic. Seriously, you just need to put on your detective hat. We're going to pull out the clues so this reads like a super simple story. So here are our clues. A man has a total monthly income of 18,000 rupees. He gives 1/3 of that total to his wife. Then, And pay attention, because this is the absolute most important word in the entire problem. He spends 1/3 of the remaining salary on his kid's education. I'm telling you, if you skim past that word remaining, you're going to get the whole problem wrong.
Okay, let's visualize this. Think of that 18,000 rupee as a giant, delicious donut. Step 1, we take out the wife's 1/3 share of that total. 1/3 of 18,000 is 6,000. Right, so that first slice is gone. Now ask yourself, what is actually remaining? Well, 18,000 minus 6,000 leaves us with 12,000 rupees. Step 2, his education expenses are 1/3 of that remaining 12,000. And 1/3 of 12,000 is 4,000 rupees. Boom, that's our second slice taken out. So finally, we just take that 12,000 and subtract the 4,000 we literally just spent on education so we can figure out exactly what's left in his pocket. And there it is. By just chunking the problem down logically, step by step, we easily cruise right to his final remaining balance of 8,000 rupees. See? It wasn't some terrifying math test at all. It was literally just following the sequence of a story. Which brings us to our final section, Part 5, Simplifying Complex Expressions. Let's level up slightly and see how this builds into some higher-level logic. We're going to apply some basic algebraic thinking to solve another super common fraction puzzle, this time about savings. Okay, so in this scenario, we're told a guy spends 2/7 of his savings and he still has 1,000 rupees left. We need to figure out what his total original savings were. Now, we don't know the total, so we're going to translate this English sentence into math by letting that unknown total just equal x. Makes sense, right? Now, if he spends 2/7 of a whole, how much of that whole is left? Well, 1 whole minus 2/7 leaves 5/7. So 5/7 of his savings, or 5/7 of x, is remaining. And the problem straight up tells us his remaining money is 1,000 rupees. So we just equate them. 5/7 multiplied by x equals 1,000. To solve for x, we just divide 1,000 by 5/7, which, remember, is the exact same thing as multiplying 1,000 by 7/5. 1,000 divided by 5 is 200, and 200 times 7 gives us our magic number. His total savings was 1,400 rupees. Following this exact, foolproof sequence just completely takes the guesswork out of fractions.
So, look at what we've done. We've gone all the way from the rigid rules of negative integers to completely unraveling complex fraction stories. And math really isn't just some abstract stuff trapped inside a textbook. It's kind of like the source code for the entire world around us. So I challenge you, try looking at your own allowance today, or even just how you budget your free time, but look at it through the lens of these fraction and integer rules. If you can decode the hidden math right there in your daily routine, what other invisible patterns in your life are just sitting there waiting for you to solve them? Keep an eye out for those patterns, and I will see you in the next explainer.